to start the second presentation. First of all, I thank Brent for warming up the crowd. It's good to have. We're not going to talk about speedsters. We're going to talk about flywheel and Magnetos. But before we start, I've got one question for you all. How many people have heard the story of how you hold the crank up with a piece of wire? As it rings, it's not cracked. How many people have heard that? How many people have tried it? And does it work?
Sometimes, right.
There is one huge crack in this crankshaft. It doesn't work. Don't try it. Spend the money and get it crack tested properly. So what we're going to talk about is how we can achieve getting the plates on top of the magnets all the same height. If you achieve that, then when you go to put the assembly together, you're going to be taking it on and off a lot fewer times and struggling to try and get that 25 to 40 thousandths gap between the plates. So the first thing to measure, I'm drawing one there, is the actual flywheel. The two areas, one is where the spool sits, and the other one on the inner side is where the magnet sits. That wants to be 0.75 of an inch plus or minus a thou. Those you will find pretty accurately. All the ones I've measured, I've never found one that's wrong. The next piece in the puzzle is the little spool. That also needs to be 0.75 plus or minus 1 thou. If you've got aluminum spools, throw them away, because they corrode and crumble and then it's going to affect it all. So just use the brass ones, okay? Next step in the puzzle is the magnet. This is one of the areas that I found the biggest error in thickness. It's very important that is the correct height. It has to be 0.75. So if you're lucky enough to have a bucket full of these, you can go through them and sort them and get a set that's pretty close. But what I found and I do is I have them surface ground, so they're all the same height. Okay? So you start with a set that is all the same height. It's fairly easy to get done, and it just saves a lot of time, particularly if you haven't got a bucket full. And the next piece in the puzzle, and again, I found an awful lot of problems and errors in this, and that's the plate, the keeper plate. The problems I have found is if you have an original screw and an original plate, the head of the screw will be just below the surface, which is what you want it to be. Some of the reproduction screws, some of the reproduction plates are machined to the head of the screw is too small and the countersink in the plate is too deep. And what happens is the screw goes down to the bottom. When you tighten it up, it bends the plate like that. You don't want that happening. The actual Ford drawing, we'll show you that in a minute, shows that there's a shape. It's actually curved. I'll pass these around in a minute. It's not flat, it's got a curvature on it. And that's so that when you pull the screw down, you're pulling it down and you're leveling it out and getting it nice and flat. So I'll pass that round to say there are several different combinations that don't work and it's hard to use the screws once you've taken them out. One method I thought about doing is to countersink the back of the flywheel so that when the original screw comes back and it's flush with the flywheel, you can pin it into that countersink hole. And that's a possibility. And then there's another piece here that I'll send around. It's a plate I designed to give more stiffness in the middle, so that when you tighten it down, it's really going to lock it down onto the plate and not going to be moving around.
On the magnet, start with a 3/4 magnet, then you just surface grind, make them all
Surface
uniform.
grind, you get your set of magnets,
Yes.
measure them, find the smallest one, and machine the rest down to that one size.
So it might be under 3/4.
Yeah, I think I missaid that.
Okay.
With this dimension, it doesn't matter, because you're just going to put the plate on the top. Anything you take off, you can adjust with the shims.
You can buy these.
No, I designed it and made a few and decided not to make any more. But if you want the drawing, I'll give you the drawing. There's a picture of the magnet that's been ground. There's a picture there on the left is the original plate and screw. As you can see, it's just below the surface. The right one is the original plate with the reproduction screw. And for some reason they do not make them. The head of the screw is smaller than the original, and that's why it's below the surface. The first option is the one on the left. Second option is the one on the right, because it's not too bad when you've got an original plate. But be careful with the reproduction plates and screws as a combination. I've seen some really bad ones, and they just bend up like this. There's a drawing of from the 4 dimensions. As you can see, it's got a curvature on there. Radius is actually 18 inches, if you want to measure it. That's what it is. So when you put that screw in and tighten it down, it's going to just level out and keep some tension on the screw. Yeah. Obviously, I'm sure everybody knows you have to have a pair of South Pole, North Pole, alternating around the flywheel. That's important. A little bit about the compass. You see on the left, the red needle, the north needle of the compass, is pointing to a south pole. That's what you need to have, because opposite poles attract, the same poles repel. So this is a negative, is a north pole, and the magnet is south. Okay. Now if you look in, I think it's the electrical manual, it shows you using a magnet, a compass, to set the flywheel in the car to recharge the magnets. That's always a possibility to do that, but be aware that if you're doing it, there's a possibility that the magnets are not very strong, and if you're trying to get that magnetic field through a cast iron bell housing, it probably isn't going to be very strong, and it probably won't be enough to move the needle. So you've got to be really careful when you're doing that. Aluminum bell housing, hogsheads, is a little easier. You get more of the magnetic field through. So that's something to be careful of. The other thing to be careful of when using a compass around this device, I found this out by experience, don't leave it on top of the magnets. Because you know what happens? It changes the polarity of that. And I stood in my barn one day looking at this and I'm going, I know north is up there, but it was the white needle pointing there. Turn round. I scratched my head for days and then I realised what had happened. So I went and bought another one to prove it. And this one I don't get too near the flywheel, but he can catch you out. Now when you have it all assembled, you then want to go around and check it. I've seen people use I don't know, it's a KR Wilson tool device. You rattle around and you beat the screw and rattle around. I don't quite understand how that works. I don't like the thought of beating the screw because you're bending the screw, you're stretching the threads, and then you've got to retighten it, then that's going to reposition the plate again. The way I like to do it is this way. I can't pass the flywheel round, but it's just a piece of steel that fits inside the flywheel, magnetic base and a dial indicator. So much easier, so much more accurate. If you want to have a play with this afterwards, come home, take a play with it. But it's important to get them all within, I would say 5 thou of each other, 10 thou at the most, and you should be able to achieve that. Sometimes you'll have to play around with the plates because the thickness of the plate might vary depending on whether you're using original ones or whether you're using reproduction ones. There's always a variance there. This is my method of magnetising the magnets, only because I haven't got something to do them individually. I think that probably is the best way to do it if you've got the means to do that. But what we do, we sit the flywheel on a bucket, plastic bucket, put the coil ring on the top of it, line it up, and use 36 volts. We've tried 24, it does it not that well. But if you use 36, it definitely does a much better job. And if you do that 2 or 3 times, you'll be able to lift the coil plate up and the flywheel won't fall off of it. You'll have to get a lever to break it loose. That's when you know you've got the best results. Well, any questions? It's a little bit brief, a little bit short.
I missed what you said about bending it apart. What screws do you use?
Well, if you're fortunate enough to have some good original screws, you've got to be a bit careful because the brass screw is, you can shear those off. So using original screws, there is a little bit of risk there, I suppose, because they're maybe 100 years old. But if not, you've just got to use reproduction ones. But just have a good look at them before you use them. Make sure the head is going to be smaller than the original ones for sure. I haven't seen one that isn't. But if you've got original plates, that's what I would really search for, original plates. Then you've got a good chance to get that reproduction screw, and then it should be okay. It won't go right to the bottom of the hole and deflect the plate when you tighten it. And does anybody use that tool? I've seen people use a lead hammer or copper hammer, and they tap the top of it and try to make it lower. I don't get that. But the biggest error for sure is going to be your magnet. That's the piece that's going to be all over the place. As I say, if you've got a bucket full, you know, when if you think about it, back in the day, the magnets were machined in that area, and they obviously were machined for a reason. That's to get everything the same height. But over time, those flywheels have been taken apart. The magnets have been spread out all over the place. Now you've got a set of magnets which weren't machined at the same time. So that's why I think you get so many variants. So you can, if you've got a bucket full of them, and you can go through them and find them. But the simplest way is to machine them.
So a method to check the magnets is, I know when they're good, and I know when they're bad, but what is the margin from good to bad that's still acceptable to run okay on the magnet?
That in terms of what?
Magnetism. Is there a test?
Well, if you're doing it with a single, if you're magnetizing them singly, individually, then I think it's a 2 pound weight, people say, or a piston will go on, and that's a good test.
Good charger, you should get about 4 pounds anyway.
4 pounds? 4 pounds. Do you do it individually?
No.
Yeah, I think it's the best way, but if you haven't got the equipment to do that, this is definitely a good way of doing it.
So you hook that up in one place, or you move the you do it in just in one location?
Yeah, just in one.
Not coil ring, that's coil ring. Oh, yeah. Ground it and hit it with the use.
Yeah.
Oh, okay, so you don't have to move it to.
No. You typically do it 2 or 3 times, and then, as I say, you should, with a 36 volt battery system, you lift the flywheel up with it. I think that's a pretty good test. Any other questions?
Magnet we were passing around here had 387.3 written on it. That magnet we were passing around had 387.3 on it. Is that grams?
No. Where is it?
Back here. .732?
No, there's another number on there somewhere, like 387.
It might have been. It might have been when I was playing around.
The reason I asked is I went through a pile of magnets and tried to get them all about the same weight.
Well, that's another good thing to do for sure. I think I may have been weighing a set for my speedster engine, and in the end I decided not to use them. I decided to use an external wash pack, get rid of the weight, get a set all the green and weight.
The other question is there any reason not to just put shims under the spools?
If it's a brass shim, it should be alright. Again, I've measured a lot of those spools, and they're pretty close. Usually find a good set.
I like the idea of bringing the thing up rather than whacking on it with a hammer. I don't like the idea of pounding the magnets.
I've worked on racing engines all my life. Attention to detail is instilled up here, and beat it with a hammer. Not what you do.
Yeah.
He did. I had words with him too. Okay, is there any questions about what we've got here? Sorry it's a little bit short, but I was asked to do this on short notice, and this is the best we could put together. If you want to come and play with the flywheel and the dial indicator, see how it works, come help yourself. Thanks for coming. Oh, before you all go, just let me just talk about the museum here. For those of you who came last year, we opened up the vintage Ford. That was it was open last year. Since then, we've opened up the agricultural room, and now we're working on the machine room. So there's been a lot of volunteer help in doing all that work. If anybody's got any ideas that you see that maybe you don't think is correct, we're trying to keep it as period correct as possible. If you've got any ideas, any suggestions, don't hesitate to come and talk to me about it, because that's the only way it is. It's your workshop, your machine shop as well as mine, and so I want everybody to feel that you can come in and the idea is that the machine shop will be a working machine shop. We'll be doing babbiting seminars in there, and machining the blocks. So there'll be an electrical section in there for generators, coils. So it'll be a workshop, a working workshop.